Hello everyone, welcome back to the AWS Cloud Engineer Essential series. My name is Dheeraj and in today's tutorial we are going to explore one of the most powerful features in AWS for scaling your applications, which is known as Auto Scaling Group, and in short it is called as ASG. So Auto Scaling Group automatically adjusts the number of EC2 instances in your environment to match the demand for your traffic which is incoming to your application. It helps ensure your application remains highly available and cost efficient by scaling out during traffic spikes and scaling in when the demand is low so that you can save cost. So in this video, we are going to cover what is auto scaling, what is its importance, the key components of auto scaling group, different types of scaling policies that we have, and at the end, we are going to do a hands-on demo where we are going to implement and see how auto scaling works. So let's get started with ASG. So let's start with the basics. What is autoscaling? So autoscaling is an AWS service that automatically adjusts the number of EC2 instances in your environment based on demand. It ensures your applications always maintain the right balance of availability and performance. During high demand, autoscaling can scale out by adding more instances, and when traffic drops, it scales in, removing unneeded instances to save cost. When combined with elastic load balancer, auto scaling delivers a highly available, fault tolerant system that adapts seamlessly to the changes coming in from your traffic. So in short, auto scaling helps your apps stay reliable and cost efficient without manual intervention. Now let's break down the key components of auto scaling one by one. First is launch template or configuration. So this is kind of blueprint for new EC2 instances that you want to launch as part of your auto scaling group. It defines the AMI, instance type, key pair, and security groups that you want your EC2 instances to have when the auto scaling group is going to create the EC2 instances for you automatically based on your configuration. Now, second component is auto scaling group. So this is a logical container that manages your fleet of EC2 instances. It ensures the number of running EC2 instances always match your desired capacity. For example, if you have an Amazon website, and in that Amazon website, you know that by default, you require two EC2 instances to be up and running to serve the traffic always. So you are going to make sure that the minimum EC2 instances that should be always up and running should be two. And during the heavy traffic, when you are having Amazon sales, at that time, it is going to grow gradually. So that is how you define the minimum capacity as well as the maximum capacity, and auto scaling group makes sure that your minimum two EC2 instances is always up and running and you don't face any downtime or outages. Now let's talk about scaling policies. So these are the rules that tells AWS when to add or remove instances. For example, scale out when CPU utilization is above 70% and scaling when it drops below a threshold. So in today's demo, I'm going to show you that when your CPU spikes above than 50%, how it is going to expand and launch a new EC2 instance for you, and it is going to route the traffic to that specific EC2 instance. Now talking about health checks, auto scaling constantly monitors your instances. If one becomes unhealthy, it is automatically going to be terminated, or it is going to be replaced with the new one, or it is going to bring up a new server. There are multiple patterns of it you can select while you are creating your auto scaling group. And together these four components makes auto scaling self-healing, cost efficient, and highly reliable, ensuring your application always run at the right scale. Now let's talk about different types of scaling you can configure in an auto scaling group. First, the dynamic scaling. This adjusts the capacity based on the real-time matrices like CPU utilization, memory, or network traffic. For example, if your usage goes above 70%, auto scaling group can automatically launch a new instance for you that we will see in few seconds. Second, scheduled scaling. Here you define fixed time when scaling should occur. A good use case is scaling up during business hours and scaling down overnight to save the cost. For example, if you have a team of machine learning engineers, at that time, you know that they work from 9 to 5, and that is the time that they would require some instances to work upon. So at that time, you can go ahead and scale the EC2 instances so that they can come work, and as soon as they are gone, automatically it is going to scale down the EC2 instances, which is going to save your cost. This is another way of taking advantage of auto scaling group. Now, third is predictive scaling. This uses machine learning to forecast demand and automatically adjust capacity in advance for you. For example, if your traffic usually spikes every Monday morning, predictive scaling will add capacity proactively. You don't have to do it. All these policies are tied to CloudWatch alarms, which monitors the metrics and triggers scaling actions when the thresholds are reacted. So whether it is a real-time, time-based or predictive, auto scaling makes sure your application always have the right resources at the right time. Now, let me talk about what exactly we are going to implement. So first we are going to create a launch template. In that, we are going to say that which AMI we require, what is the instance type we require, what is the VPC we are going to use. So these kinds of all basic details, or if there is any commands that we want to run automatically while the EC2 is going to get launched to install some software, we are going to add that too as part of user data in step 1. Now in step 2, we are going to create the auto scaling group where I will say that my minimum number of EC2 instances that I require is going to be 1 and maximum is going to be 3. Then in step 3, as part of the auto scaling group creation itself, I am going to attach this auto scaling group to a application load balancer that we will create at the time of creation of auto scaling group only. Once these 3 configurations are done, then we are going to go ahead and log into EC2 instance, which is going to be already created by the auto scaling group. Once we log into instance, so our minimum capacity, desired capacity of EC2 is 1, right? So after we create our auto scaling group, it is only going to create one EC2 instance. We will log into that EC2 instance and we will create a artificial load on our CPU. And during that, we are also going to set a dynamic policy, which is going to make sure that if our CPU is going to cross the range of 50%, it is automatically going to go ahead and create a new EC2 instance. That is the beauty of auto scaling group. And we are going to do everything, all these steps from our AWS console. Now, before going to that part, this is what we are going to implement. So first, we are going to create an auto scaling group. As part of that auto scaling group, it is going to create an application load balancer, that is this. Then under this application load balancer, we are going to map the 3 subnets, and this is our auto scaling group. What is the work of auto scaling group is, as soon as for our desired capacity, first it will launch one EC2 instance from any 3 of them. Once it is launched, and if we require more, it will launch it to another subnet, that is another availability zone. And then if it requires a third, it will launch it in the third one. In this way, your application becomes highly available. So in case if any availability zone goes down, it is going to be resilient to that. Now let's jump to our AWS console and get started. So to create auto scaling group, first we are going to go in EC2 console. Once you are in EC2 console, on the left hand side, first we have to create launch templates. I will click on launch template and create launch template. In this, I will say ASG cloud engineer demo template. Okay, now this template will launch an EC2 with a web server installed on it. Now, if as you are a beginner, if you just checkbox this, it is going to help you know that which are the required fields that is mandatory for you to fill. So for example, right now, you don't see anywhere it is written as required. But if I click on this, see it is saying required, fill this, required. So whatever is required, it has made it as required. So if you are a beginner, you can take help of this guidance. Now, template tags, I am going to again add the same tag over here with the value that we have. and this is our tag source template. So suppose if you have any XYZ template which is already available and you want to copy that existing template to a new template where you would be making more changes. So what you can do is you can copy the entire existing configuration and then you can add your custom configuration from there. So in that case, you don't reinvent the wheel again. So this is our fresh template. So I don't want to refer any other template. Now, like we create our EC2 instance, the same way the steps are over here. I'll click on quick start over here. I am going to use Amazon Linux. Once we use Amazon Linux, it is going to take Amazon Linux 2023 and by default it is 64-bit. So this is what free tier eligible. So I'm going to keep it as it is. Now in instance type, I am going to take T3 micro because it is free tier eligible. Again, once we select that, then I already have my key pair which I have created in our previous YouTube tutorial. I'm going to use the same key pair. Then in terms of network settings, what I'm going to do is I am going to not define any network setting over here. Let the ASG decide by itself. But for security group, I am going to provide our security group. Now this security group is having SSH port that is 2022 as well as HTTP port that is 80 enabled, because of which when I'm going to create this auto scaling group and the load balancer it is going to create, that would be able to route our traffic to the specific web server that is going to be created. Now, if you want to do advanced network configuration, you can click on this and the advanced network configuration can be done from here. I don't have to do any advanced network configuration, nor I have to define any tags. Now, in advanced details, what I'm going to do is instead of me going to the server and installing the softwares, what I am going to do is I am going to go ahead and paste this script over here, and I will also explain you what exactly this script is going to do. So this script is going to install HTTPD on our server, that is the like Apache Tomcat. So this is a web server. Once the web server is created, we are creating a file and putting that in index.html where it says that this is our cloud engineering series demo server that we have created. Once I do this, I just have to go ahead and click on create template, launch template. Once I click on create launch template, it is going to go ahead and create my launch template. If I click on view launch templates, my launch template is successfully created over here. Now, next step is I will go to auto scaling groups. Inside auto scaling groups, I am going to say create an auto scaling group. Once I say, at that time I will say ASG cloud engineer demo. I will copy this. Now we are going to select our launch template that we have created. So this launch template is created. In this, it is showing the details, that is default or one. So we have not updated that template, so we don't need to think about the versioning over here, but this is what it is. The EMI ID, the security group that we have used, T3 micro. So whatever configuration that we have, you can see it over here. Now, if I click on next and go ahead, so over here, now I can manipulate the subnets and the other details that I want to. So what I will do, I will just click on this and I will say I want to create my EC2 instance in all of the subnets while it is going to get created. So this creates high availability and fault tolerant infrastructure. Now, over here, I have set balanced best effort because this balances it well compared to the other one that is balanced only. Then I will go and click next. So in this, we have just set our subnets. Everything else is as it is. In next, it's saying, do you require load balancing? Yes, we do require load balancing. And for that, we have to attach an existing load balancer that we have already created in our previous video. If you have watched that video, you can attach it from there. If you have not, I am going to create it for you right away. Once I click on this, it is asking me which new load balancer you want to create. So I will say that I need an application load balancer, and I will change the name load balancer. ASG load balancer. So this is going to be our ASG load balancer, and I'm going to keep it as internet facing, and network would be the same. Over here, the listener port I have selected as 80. Now, as part of this, when you are setting up the listener, you also have to make sure that you are going to go ahead and have a target group. As we don't have a target group, I will just go ahead and I will say create a target group. So once I say create a target group, it is saying what is going to be the target group name. So I would say ASG target group. That is going to be the name. So this is going to create the target group also for me, and it is going to do all the mapping that is required as part of the target group. I'm not going to use PPC lattice for this, and application recovery control is also not required. But what you can do is make sure that you turn on elastic load balancing health checks, which makes sure that before it routes the traffic to some other EC2 instance, it is checking the health of that EC2 instance before routing the traffic to it. And over here, we can keep our health grace period to 300, or you can also reduce this to 100 based on the requirement, because based on this 300 and all, it is going to take time to check the health. So every 60 seconds it is going to check. So if I keep it 300, it will check after every 5 minutes. So I have just kept it as 60 for now, and I will go ahead and click on next. Once I click on next, it is asking me desired capacity. So desired capacity is minimum I need 1, but then I have selected 1 over here. There's minimum number of instances, and now it is asking if I need to scale, what it should be. So I would say minimum 1, the same, and maximum is going to be 3. So when I select both of this, and over here I am saying no, over here it is by default checked no scaling policies. We would require target scaling policy. So I will click on target scaling policy, and I'm going to configure a target scaling policy over here. It is CPU based. This is dynamic scaling policy. Okay. So over here you can see, and I'm going to keep the warm up over here is 60. Target is 50. You can make it 60, whatever you want based on your requirement. So I have kept it 60. So now, while it is going to create the auto scaling group, along with the auto scaling group, it is also going to create this policy. Now, in instance maintenance policy, there are multiple options. As I said previously, you can define it by yourself. But right now, I'm not going to keep any policy. But if you want, you can select based on your preference. Now, default reservation preference, I am keeping it default again, and it's saying instance scaling protection. If protect the scale is unable, if protect from scale is enabled, newly launched instances will be protected from scale. So it's saying that when we are scaling in, do you want to delete an existing EC2 instance? So I am not going to enable any of them. And over here it's saying enable group matrices collections with CloudWatch. You can select this if you want to use. But this is a good option. And for default instance warmup, this is a very advanced features, and this is very useful. You can explore it further. For now, we are not going to talk about it. Now I'll click on next, and it is going to ask me for any additional notifications that I want to configure. I don't want to, so I'll click on next. I don't want to add any tag, but we can say the same as ASG Cloud Engineer Demo Lab or Cloud Engineer Lab, and I will say next, and we are done. So what we have done, we have selected our launch template, we have selected our network, we have selected load balancer, we have selected target group along with load balancer. These two we have not done anything. It is by default disabled. We have set the health checks. Then we have defined the scaling policy as well as the group size. So over here, you will see the scaling policy as well as the group size. And for other options, we have kept it as default. And at the last, we have added the tag. Now I will just go ahead and create auto scaling. Before that, let me show you. Right now, if I take you to the EC2 console, in this EC2 console, you won't see any instances running. Okay, the running instances is 0. If I click on this, still it is showing as 0. But now when I'm going to go ahead and I am going to create the auto scaling group, as we have set minimum desired capacity is 1, it is going to make sure that one EC2 instance comes up and it is up and running. So I will click on create auto scaling group. Now it is going to create auto scaling group, which will take 3 to 4 minutes to provision each and everything, because it is going to provision a lot of things. Like for example, I will show you what other things. So it is going to go ahead and create your load balancer. See, it is provisioning all load balancer. Then it will create auto scaling group. This is also been created. Now if I take you to instances and click on dashboard instances, over here you can see an instance is also been initiated. So this is the beauty of using auto scaling group. So if we go back, so as part of the auto scaling group, whatever configurations we have, what all things has been achieved. So auto scaling group, just a minute. So as part of auto scaling group, it has provisioned the application load balancer, and this application load balancer is tied up to subnet 1, subnet 2, and subnet 3. Now what it is going to do is, at the current moment, if I go over here and I see this is been tied up to 1C, right, as you can see over here. So right now the first server that it has launched is in availability zone 3. Okay, now when it is going to launch the second server, it will make sure that it is launched into availability zone 2 or 3. So previously I have not mentioned that it has to start with 3. It has picked it randomly. And what is the role of this auto scaling group? So this auto scaling group is going to make sure that if anything happens to this server, or if the CPU load is more than 60%, it is going to go ahead and spin server 2 over here. And then if the same happens with this 60% is crossed, it will go ahead and create server 3 over here. And that is the max thing. So if it also goes ahead and crosses 60% of CPU utilization, then it might result in some outage. And so this is the patterns that people implement, and later on, based on their learning, they configure it appropriately. If they want to change it, they will change it. Or if they want to learn any new pattern, they will learn a new pattern out of it. So that is how ASG got implemented. Now it's time for action. So for that, what I'm going to do is I am going to go ahead and take you to the console again. Okay. So we are on the console. Our EC2 instance is launched. Okay. So there is one EC2 instance launched, and this is our auto scaling group. Let me click on this auto scaling group and let me show you what all things we have. So these are all the configurations as well as integrations, automatic scaling. So there is one monitoring activity thing over here. So this activity shows that what all is happening as part of your auto scaling group. So this is what it has done till now. So it has created a load balancer, it has created a target group, it has launched an EC2 instance, so it has logged everything. So if you want to see the activity that ASG is performing, you can go ahead and check it from there. Now, if I click on details, it is going to give you details of launch, template, network, health checks, and everything that we reviewed. But if you want to see the auto scaling policy that you have created, so see dynamic scaling policy, we have this scaling policy enabled. Now, with the help of this scaling policy, I'm going to show you how it is going to expand. Now, for doing that, I am going to go ahead and log into our EC2 instance. So let me pull this up over here for you. So I am going to click on this, connect, copy this command, and I am going to paste it over here. Once I paste this command, I will say yes, and I am inside our EC2 instance. Why I am able to log in over here? The main reason for that is port 22 was open as part of our security group. Now, as we have already logged in to the server, the next step for us is going to be we have to install stress test. So for performing the stress test, I am going to run a command sudo dnf install stress. So I have to install stress. Once I install stress, see it is being installed successfully. I will clear this, and then I'm going to say stress hyphen CPU 2 hyphen timeout. So let me explain you what's happening. It is going to create stress on our CPU, and this is going to create stress for 300 seconds. That is around 500 minutes. So when it starts creating stress, we can monitor that too. I will show you. So first I will go back to our EC2 instance, click on instances. Once we are in instances, I am going to click on our server over here, and over here we'll go to monitoring. Inside monitoring, we are going to open CPU utilization. So now the server has just launched. That's why you don't see much of the CPU utilization, but I will make it as 1 minute. Oh, sorry, not 1 second, as 1 minute. Where is 1 minute? Yes, 1 minute. So in some time, it will start showing up a lot of things over here that how the CPU is being utilized by our EC2 instance. Okay, so I will just close this. First, I will refresh, and I'll say instances, dashboard, refresh it, running, select this, monitoring, and I will just expand this. So guys, you will have to keep patience for this to work. This takes time because CloudWatch has to capture the monitoring activity. So right now there is no activity showing. See, it has started capturing the activity where it is showing that right now the CPU is at 0.29, means this percent of CPU is being utilized. So it will keep on updating that. Meanwhile, I will go ahead and run this command, which is going to create the stress, and I'm going to hit enter. So before that, just a disclaimer, I will again open EC2 instance over here, and I am going to keep on refreshing for you guys over here that there is only one EC2 instance right now. When I'm going to create this stress, the policy is going to get triggered, and once the policy is going to get triggered, it is going to go ahead and launch a new EC2 instance. What we can do, one more thing is, I will take you to CloudWatch. CloudWatch. So in CloudWatch, if I take you over here, you can, when there will be an alarm, that means the rule that we have created a dynamic. So when it is going to cross 50%, one alarm will be triggered over here. If you see that alarm, that means it is going to take action by default. If you don't see, that means there is some issue with your scaling policy. So we have set everything. We have our monitoring enabled. I will keep on refreshing it. See, now it has starting showing. So it is 0.8 at the current moment. So I am going to hit the stress test, and it is going to definitely cross more than 90%. So at the current moment, this is the message that you will get, that dispatching hops. That means it has started successfully. And now we will wait for some time and keep on refreshing this. So we will come to know that how many percent of CPU has been utilized. So, and we will also monitor the CloudWatch console to see if there is any alarm been raised for the same, because once the alarm is raised, then and only then auto scaling group is going to trigger new EC2 instance. So let's wait for a few minutes. So meanwhile it is running, we can go ahead to our auto scaling group to check, to the load balancer, and try to see if it is routing the traffic to one of the server that we have launched. So if I click on this and I take the DNS, enter, no. So the web server is still trying to check if it is up and running. So this will take some time, but this will happen gradually. So for that, you can also check the load balancer, and you can check the target groups. In target groups, it will show. So it is showing as healthy. So it will take some time, but it will load very soon. Or maybe it is creating a new agent. That is the reason it might take some time. And if I go over here, see guys, it has started raising. So now it was 0.8, now it is on 14. Okay, so it has started doing this work. So guys, I have again just refreshed and you can see it has crossed 60% and now it is in 80. So if I go over here and if I try to reload this, I'm sure it will catch. It should come in alarm. So the alarm is not yet triggered. Once there is one alarm being triggered, then and only then it is going to go ahead and perform some action of scaling out. So let's wait for the alarm. So CloudWatch is still processing it. So guys, I just refreshed the screen. After refreshing the screen, you can see now there is one alarm which is in red. If I click on this in alarm, that means now they have notified that we have to create a new server. And this rule that we have set, that is a dynamic policy, it has triggered a notification. Once this notification is triggered and once it comes in the state of alarm, it's time for ASG now to go ahead and spin up a new server. So if it's in alarm, in fraction of second, if I try to reload, I am sure it has started creating the new server. And that is how auto scaling works. So if you are setting a dynamic policy, as soon as a notification alarm is being triggered on CloudWatch, in the behind the scenes, this is how it works. Once this notification, that is the alarm, comes, automatically auto scaling group is going to take the action which it has already taken, and then you can go ahead and check whether your server is up and running or not. So now the server is going to be up and running. So if I go ahead and run the same stress test on the second one, that is our second instance also, it is going to also perform the same activity. And the important thing to notice over here is previously the availability zone was 1C, now it is availability zone is 1A. So you can see that now it is distributing it in a high availability manner where we are not going to encounter any outages, and it is making a fault tolerant implementation for us. And if I click on refresh, in some time this initialization will finish and the server will be fully up and running and into the traffic. This will take around 4 to 5 minutes for sure. And coming back to our slide, so let's talk about best practices before we close. And first, always deploy your auto scaling group across multiple availability zones as we did. This ensures resilience and keeps your application available even if one availability zone goes down. Second, attach your auto scaling group to a load balancer that I have already showed you. This makes sure traffic is evenly distributed across all the healthy instances, improving fault tolerance. Third, take advantage of lifecycle hooks. So that is the advanced part that you can explore. So there is one option of lifecycle hooks. This allows you to run custom actions when instances are launched or terminate, such as running setup scripts or sending notification. For example, if my alarm is breached, it can go ahead and send a notification, email notification to the team saying that dude, the alarm is breached and the new instance has came into picture. So they can go back to the server and see why the CPU utilization is so high. Sometimes it's not only because of the traffic which is coming in, there is some system issue also that the admin can go ahead and rectify. And finally, use CloudWatch monitorings and notifications as we saw. This gives you the visibility into scaling events and helps you stay proactive with performance and cost management. By following these best practices, you will keep your auto scaling group robust, reliant, and cost effective. So before we close this, if I take you to the auto scaling group, I am sure in monitor, not in the activity section. See, the new activity has also been launched, has also been tracked, where it is saying that it has launched a new EC2 instance, and it has launched the instance because a alarm was triggered, and this was the alarm that I showed you over here. Now it has the alarm has been settled because it has been taken care of, but when the alarm was triggered, it has captured that alarm, and based on that, it has increased the capacity from 1 to 2. So 1 to 2. And that wraps up our session for autoscaling group in AWS. We explored what autoscaling is, its core components, how to create an autoscaling group, types of scaling, and even walk through a demo. So thank you so much for watching. My name is Dheeraj Chaudhary, and I hope this session gave you the confidence to start working with autoscaling groups in your AWS projects. If you found this helpful, please like, share, and subscribe to the channel, and hit the bell icon so you don't miss the next upcoming video in the AWS Cloud Engineer Essential series. So I will see you in the next video, and bye for now.